Now, liquids do expand on heating, right? On absorbing heat because it's a property of matter. But we have an anomalous expansion in case of water. We can understand this concept with this graph. Suppose I take volume on this axis and temperature on this axis, right? Let's say the volume is in units of 10 raised to power minus 3 per kg cube in what? Meter cube. And temperature is in degrees Celsius. So you'll see that at 0 degrees Celsius, suppose volume of water is this much, it is, okay, I'll start it with here. It will initially decrease with increase in temperature and then it will increase again. This is called anomalous expansion in case of water. The values are something like this. This is this value and this value. The values are, this is 4 degrees Celsius, this is 100 degrees Celsius, this is 1.000 and this is 1.0434. So the values represent here that at 4 degrees Celsius the water has minimum volume, so it actually decreases in volume. So what is happening? With increase in temperature, the volume is not expanding, it is decreasing. But from 4 degrees Celsius to further 100 degrees Celsius, the volume of liquid or the water increases, right? So this behavior is not usually observed in any other liquid other than water. That is why it is called anomalous expansion. The reason behind this is the type or the nature of bond of hydrogen and oxygen atom in water molecule. So this bond is basically responsible for this absurd behavior of water in case of expansion. So here we conclude with this, that volume of water initially decreases and then it increases. That means water will have maximum density at 4 degrees Celsius, and that is why we consider this value to be the most relative value when we take on calculations, that the volume of water is 4 degrees Celsius, which is, or density of water is 1000 kg per meter cube at 4 degrees Celsius. So water has maximum density at 4 degrees Celsius and then the density decreases.